Hello and welcome back to Make Magazine's electronics course. This is lab number 13. Well, actually it's a substitute to lab number 13. I'll explain what lab number 13 was. Lab number 13 was demonstrating the use of heatsink and heat distribution when soldering and precautions when soldering. I'll explain the lab, but I didn't feel like it was necessary to demonstrate it. Also, I didn't have some of the equipment that properly demonstrated it and it explained it correctly. So, the lab was about how soldering guns get hot when you're soldering. That's how they work. But electronic components can be sensitive to hot things, and especially, well, as demonstrated in that lab, an LED. The lab was to use hooks to have it. You don't use your helping hands to grab the LED. You grab the LED by the tip, but then you just make some hooks out of the ends of the LED, and you loop it up to a resistor and a battery, and you solder while it's on, I believe, or not while. Yes, you solder while it's on, and you hold it. That you just hold the soldering iron on the wire and watch the LED burn out or broil, depending on what happens. Given that there's no heat loss, and then you try it again with. Technically, you're supposed to have a pencil soldering iron, a 15 watt, and a 30 watt regular soldering iron. I don't have a 15 watt. I only have a 30 watt or more than 30 watt, but I know how to, but I have a dimmer on it. So I couldn't really properly demonstrate the lab. And then they have you use a copper alligator clip as a heat sink to draw heat away, because heat will be gone. Heat will go where the energy is trying to settle out and distribute evenly, and you spread it out into something metal, which is a good conductor of heat. You can spread it out through that too. Hence why you hold the LED by the tip, because the plastic on the LED is not a good conductor. But I didn't feel it necessary to demonstrate that lab. Also, I didn't have some of the equipment to demonstrate that lab. I didn't have... Yeah. So, instead of doing that lab, I will be showing you a concept of something I found interesting, and looked ahead in the electronics course and never found it in there. So, here's a little circuit I designed specifically for this lab, and I'll get into why it's dark in this room in a minute. It runs off 9 volts. I'll put a schematic in the video right around now. Okay, in case you're wondering. Runs off 9 volts. Unplug the circuit so nothing unexpected happens. We've got, from our positive, we've got as we can see here, maybe you can, maybe you can't, I don't know. I'm going to turn the other part of the light on so we can see a little bit better. We have a 330 ohm resistor, and the positive, that's going to the anode of this LED, which I carefully selected because it was lower powered. And the anode of the LED is going to this transistor. This is an NPN transistor. It is a... I can't read that. Just let me look at what type it is again. Just hold on a second. It is a BC 547 NPN transistor. You can look up more on the specific transistor if you want, but I carefully selected it just because of some of its properties for this lab. So that's attached to the collector of this NPN transistor, the cathode of that. Then we also have another resistor, as you probably won't be able to see, 220 kilo ohm resistor. That's on the positive, and it goes to the base of this transistor. As we can see, sorry it's a bit fuzzy, it also goes to this little thing. Now this thing is not something we've seen before. This is another type of resistor, but it's a photoresistor. It uses a chemical that's light sensitive, and it reacts. It's a very chemical process. It's a natural kind of process. It's not something really complicated and artificial, as you can see by the size. And if you look at the cost of them, you can see it by the cost. It's a very simple concept. Really, it's not a simple concept, but it's a concept that works very well, and it's mostly natural. it's not natural, meaning it's all green and, you know, that sort of thing. It's a natural sort of, it's not something synthesized and manufactured and meticulously designed to be to have differing resistances based on light. Sorry about that. Now this thing, when the more light there is here, the more light there is, the more resistant the resistor is. I believe that's how. Yes. Wait. Yes. The more light there is, the more resistance the resistor provides. So brighter is the lighter. If you just hooked it up in a simple circuit, the brighter it is, the brighter the LED would be. But that's useless, as we know. I mean, it can be demonstrated, sure, but it's useless because if it's already light, why do you need another light source? So, and then we've got that hooked up to the base and emitter of this thing. And then we also have the emitter simply going back to ground, negative. And the resistor. So, given that I find that having more light when it's brighter already is kind of useless, I figured why not make one that's the opposite. Now, there is such thing as an inverter, but you can use an op-amp, which is an integrated circuit I don't understand, so that's why I avoided it. But I do understand NPN transistors, so I thought maybe there's a way to make a kind of inversion process with this transistor. And there was, and I'll explain that in a minute. You can use any transistor, but this one, any NPN transistor, and you can try any NPN transistor, but this one turns out to be the most effective of transistors. Yeah, just a moment. Let me look something up about it. The camera's going to be pointed here from now on, by the way. Just because, I want you to see what's going to happen here. So let me move stuff around. So here is our photoresistor. I'm going to turn off one light. Photoresistor, and here's our LED. That's what we're going to be watching once they start. Let me just look up some information about this. I'm looking up a data sheet. Okay. The signal NPN transistor. Not positive what it does. Okay. It's just a transistor. That's the point. It's an NPN transistor, and it's a specific type. Specific types just have varying, very tiny things about them that I don't understand. Not many people do in some ways. But the point is, it's the right kind of transistor. I've done some research into this. I obviously didn't just randomly pick that one and figure out, oh, it's the best. I'm not an expert in semiconductors. So, let's give this a try, shall we? But the question is, how do we give it a try? I already plugged it in. How do we give it a try? Well, the fact that we have a light-sensitive object here is kind of a hint. So let's just see what happens. I'm going to put my hand here so you can see the effects of it, because sometimes it's hard to see. And as you can already see, if I put my finger over there, I'm positive why that's happening. The LED... Why does it get brighter when it gets... Oh, that's because the phototransistor has a little bit going on underneath it too sometimes. So, photoresistor, I'm sorry. So, you can see that the LED gets brighter, and the shadow that I blocked something underneath it. It's actually not my finger. It's partly my finger up there. But you can just see that the LED illuminates. Now, I'm going to turn the light off. Let's see what happens there. Immediately it turns on. And as you can see, I have nothing to do with that. But I put my finger over it. It actually gets slightly brighter. And I swear that this switch is not controlling the LED at all. They're not connected in any way. It is that phototransistor right there. I can prove that to you by just kind of covering it with this. Even if I take my hand away, it's not my hand either. You can see that thing illuminate. It's just that when you do this, when it's bright like that, it's harder to see it. Oh, you can see it illuminate. Yeah, you can see it illuminate on the camera. I can't really see it up here, but cover it with this napkin. You can see it illuminate. So, essentially what we're doing here is reversing the properties of this photoresistor, using this transistor. We can kind of follow it with our eyes if we want to. I just unplug the battery, given that we know what happens now. So let's just follow it with our eyes. Let's just think. We got power going here, limited, of course, to this LED. This LED should light up right then, but, well, we're not connected to negative yet. And there's nothing going directly to negative. We go into collector here. Okay, well, there's nothing letting us through yet, so we have this resistor here just to keep things in check. And what really, just to get power to that photoresistor, because we need power to get there somehow, but we don't want to blow the photoresistor because they are a little bit sensitive sometimes. That's why that the second resistor right there, that's why that's there at all. It's actually not technically what is connected to the base. It's technically connected to the transistor, but it doesn't matter. To the resistor, I'm sorry. So, and then we see that, so that goes into the base, so that should control how much can go through to the emitter. Also, it controls, but then we also have this going through to the base, which is technically all that's going through to the base. It's going through to the base and kind of also telling the emitter, the collector's telling the emitter what it can and can't do too, as well. And so this photoresistor right here is connecting the base and the emitter. So we're getting signal out the emitter, but then we're also getting resistance between the base and the emitter. We're getting the resistance between the base and the emitter, but it's a controlled amount based on the light. So that will control how much can go through, and hence why we get the reversing effect. That's kind of a shoddy and not so great explanation of it, but it's vague and it'll work. I'll throw a schematic in, a link to a schematic, picture of a schematic in the description. Yeah, and I'll post a picture of the breadboard setup. I'll just post a picture of the schematic. That's all. Thanks for watching. I'll see you guys next time. Sorry about not getting a real lab. It's just that lab was not doable. Thank you.